Hello folks, right, got a question here from you, a bit like the vector ones you've just been watching. You might want to pause the video, have a quick go at that. It says in a triangle, P to Q to R, P to Q is Q, P to R is R, M is the midpoint of PR. Find the vector Q to M in terms of Q and R. Have a go at those. And question 2. A and B are those. Find A, take 2B in terms of I and J. I hint for the first bit, I'd draw a picture if I was you. Sounds very confusing, but probably isn't as bad as it sounds. Okay, so pause this, have a go to say, and now unpaused, here are the answers. What you managed. Okay, so we're going to start vectors 2 now. So you maybe have your printout ready if you've managed to print out the slides. And then you can just fill in the gaps. So we'll be able to calculate the magnitude of a vector, to be able to find the distance between two vector points, to be able to find out a unit vector given its direction, to be able to give the direction of a vector by the angle it makes with the specific direction, and to be able to solve geometric problems involving vectors. So quite a lot. So we're going to start finding the magnitude of a vector. That's finding the length of the vector, isn't it? So the magnitude. Or modulus of a vector, or is its length. For example, suppose we have the vector, this thing. The magnitude of a vector is written as that or that. We can calculate this using the Pythagoras theorem. So if you want to just, oops, we'll get a pen here. Think of this as like two sides here. Ooh, not a bad drawing. Well, that to find the vector A, you do that squared plus that squared equals A squared, wouldn't you? So basically, the mod of, I'll call it that one, A to B, or we can call it mod A, it doesn't matter, equals, what's the left? That's right, 2, and that's 1, 2, 3, 4. It's going to be 2 squared plus 4 squared, and that comes out at root 20. Which, if you remember from your surds, or if you do it on your calculator, you'd have got 2 root 5. Super. 3D magnitude can also be found using Pythagoras theorem. For example, find the length of this one has magnitude, that, square and square root. And if we work that out, we get, well, I'll tell you what, we'll just think about that first. We had there the numbers remember them right, 3, that's going to be 3 there, isn't it really? 2, and why are we using Pythagoras? I'll show you. 2, and the other one was 6. So we just pretend it was this. Then what we're trying to find here is this vector A from here to here. What we need for that is, we should do it in a different colour. We need that length. Ooh, terrible drawings of straight lines, and that length. Now that length at the bottom there is a bit of Pythagoras again, isn't it? Because it's a diagonal from that and that. So actually that works out at 2 squared plus 3 squared whole square root, isn't it, that? And then we know this length is 6. So when you're trying to find that vector there, because that's a right angle there when you go down here, when you're trying to find this vector here, what you end up doing is 6 squared plus this squared, which is 2 squared plus 3 squared, and then you square root the whole thing. So that's why we can use that formula we just seen just on the side before. It's here again. Just square and square root. You don't need to show or draw the picture every time. You just pop the numbers in the sort of the formula and out comes 7 in that case. Right. If we are given the coordinates of 2 points and we are asked to find the distance between them, again we can use Pythagoras in that same way. So e.g. find the distance between the 2 points using Pythagoras. So the distance between them, basically find using this formula here, which is just your Pythagoras. Find the difference between the 2 points, square it and square root. If we do that with this example, steady hand, no. So we do that one, take that one. So 5 take negative, sorry, negative 4 would be 9. Plus 9 take 7 is 2. And minus 8 take negative 2, let's add. So minus 8 add 2 is minus 6. And if we do that calculation, we will get, I think, 11. I'd hope 11. Yes. So done. Unit vectors. Remember, if a magnitude of a vector is 1, we call it a unit vector. So in other words, its length is 1. It is possible to find the unit vector parallel to any given vector A by dividing that vector by its length or magnitude. The unit vector parallel to a vector A is denoted as A hat. So A hat in general, as the formula, is the vector A divided by its length, to make it of length 1. So find the unit vector parallel to this thing. So we need to find its length. So its length would be a bit of Pythagoras. 4 squared 16, 1 squared 1, and 1 squared 1. So root 18, which works out, if you're doing it on your calculator, as 3 root 2. So our B hat then will equal 1 over 3 root 2 of the vector. I'll do it as a column vector, if you remember, that's 4 minus 1, 1. And done. Okay, on your whiteboard then, try this one. Pause the video and have a go. Okay, so we should have got square root, the length of that, 4 plus 4, because it's 2 squared plus 2 squared, gives us root 8, which ends up as 2 root 2. So it's going to be 1 over 2 root 2. The vector we've got, which is 2 minus 2. If you want, you can pull out a factor of 2, which would pull out the 2 up here, and that cancel that 2 on the bottom. And you just get that 1, 1. And if you hate that because it's got a surd on the bottom, you can always get rid of the surd on the bottom by changing that to root 2 over 2, if you want. All right, another one of these. Have a go at that one. Okay, and the answer. There we have it. Right, next section. Okay, so here we've got to find the angle a vector makes with a stated direction. This brings in what you do in mechanics shortly. So it says, always draw a picture and measure the angle anti-clockwise from the given direction. So this says, find the angle of the vector which makes with the I and the J axis. So this is a vector, it's going along 5 and up 3. That's what that arrow is meant to be suggesting there. So if it was doing that, this would be our y-axis and that's your x-axis. And if you remember, the I is just 1 unit in the x and the j is 1 unit in the y. So this question is asking what's the angle it makes with the direction of I. So let's put A, change the colour here, let's do it as black. So anti-clockwise from the direction I is in fact that angle there. And to get that angle there, we'll call it theta. We do a bit of trigonometry. Now remember, this is up 3 along 5, so it would be tan to the minus 1 of, oh, so that's our theta. Tan to the minus 1 of opposite over adjacent, and press the buttons and out comes 30.96 degrees. Part B, looking from the direction J, so here, we've got to go anti-clockwise, so that in fact is a long, well, a big angle. It's going all the way around there. That's probably various ways of getting this, but if you think of your angles, if you go all the way around in a circle, it's 360. So we could work out this angle here and take it away from 360. Or we know that going around here to there is 270. And then we could just add the angle theta. So if we call this angle, let's call it alpha. Alpha will equal 270. So that gets you from there all the way to there, plus theta. And if we do that, that's that 30. If you add that up, that gives us 300.96 degrees. Right, this is a vector. Same thing for I and j, but this is the vector. It's going backwards 5 and up 2. So our I and j are still here. If you remember these, let's put these on red. Here's your y-axis and your x-axis going along here. I'll increase the x-axis going that way as well, but this x-axis is going that way. So the I is there and the j is there. Oh dear. Right, so A. So we're doing it from the I-axis. We're going to go anti-clockwise. So it's looking, well, it's looking at that, isn't it? Call that theta. So to get that, we really need to work out this little angle here first with our trig. It only works out little acute angles nicely. So if I write this one first, alpha would equal tan to the minus 1 of opposite over adjacent, which works out as opposite is the 2, adjacent is the 5. Don't put in minus 5, it just confuses matters and gives us obtuse angles. So if you just do that, you get a nice acute angle of, I might have to work that one out. 21.8, I think. And that makes theta 180 minus that, which gives 158.2 degrees. Right, part B, we're going to be able to squash it on. B is the angle it makes from the J-axis, so that's easier. That one there. Ooh, well, let's call that phi. That's a bit of introduction. So phi equals, and that one you can get by doing 90 minus alpha. I hope you can see that angle there. So 90 minus alpha, and if you do that, you get 68.2 degrees. Job done. Find the angle the vector makes with the I and the j. So we've got another one of these. So I'll put our I and j axis on here. Should have done before we drew the thing really. It's gone down 7 and it's gone along 4. So, oh, come on. That's your x-axis. And here's your y-axis, but j's in that direction, isn't it? J. And i's in that direction. There. Right, so the angle it makes from I anti-clockwise. So that would be that big angle all the way around there. So my suggestion here is we need to find this acute angle there and take it away from 360. So if we can find alpha, alpha will be tan to the minus 1. It's gone along 4 and down 7. So just, as I keep them positive to get an acute angle. So just do that on your machine. If you do that on your machine, I've done that right, wait a minute. Opposite, if we draw that down there, opposite is a 7. Oh dear, that wrong way around, I'm going to have to rub those out. Over adjacent, which is the 4, silly me. If you do that on your calculator, what do we get? I'm unsure. Oh dear, calculator's having a mare. That gives 60.26 degrees. Therefore, our, I'll call it, we didn't really call it anything, didn't we? Call it theta. Theta equals 360 minus alpha, which is, cheating here, look at my notes, 299.7 to 1 degree. And then the other one, let's hope it's a nicer Come on, let's go anti-clockwise from J. So, oh gosh, come on. That's that angle there. Colour it in, you see. I like colouring, don't we? Right, that angle there, let's call that one thigh. So B, thigh. So that's 180 plus that, or you can think of it as 270 minus alpha. I think I'll do it as 270 minus alpha. Oh, 70 minus alpha. And if you do that on your calculator, you should get 209.7 degrees. Done. Right, this question says the vector v has a magnitude of 7 and makes the angle 62 above the I direction. Write v as a column vector. Well, what's going on there then? So, oops, that's bad, isn't it? So here's your I direction. It's the x-axis. It's saying it makes an angle of 62 above it. It says this thing's got a length of 7. So again, all we're having to do to find actually this as a vector is that how many up, how many along. We can use a bit of trig. So we know this is an angle of 62 and that's the hypotenuse. So 2 bits of trig really. We can do, well, we know that cos of 62 will equal adjacent over hypotenuse. So I'll call that the x over 7. So if we just rearrange that to find x, and you end up with x being 3.29. And if you do the other one, that'd be sine 62. That equals opposite over hypotenuse. If you mix that one up, change it round, you end up getting 6.18. So it says write it as a column vector. So our answer would be 3.29, 6.18 as our vector. That's our vector V. Right, hope you understood those, because it now says some questions 1 to 6 from an exercise. Put those on the next bit you're about to see on the video, so you might want to pause them and have a go at a few. As I say, you don't have to do all parts of every question. Just spend about 10 minutes having a go at some of these. So pause this now, please. Have a go at what you want to have a go at. You might find, I'm just looking at it there, that's a bit tricky at the moment because you haven't done trig, so let's cross that out. But you can maybe have a look at some of the others. Have a go at them. So pause this, say please don't do them all, just pick and choose for 10 minutes. And then unpause now and have a look at the answers. Here they come. And here are the answers for those questions. Okay. Hope those make sense. We're now moving on to look at the geometry, a few geometry problems. So this one. It says if we were to prove, or we had to prove, ABC is a parallelogram. That's a parallelogram, the blue one, if you're unsure. We only need to show that the vector A to B is in fact the same as, I'll just draw it and then we put these letters on. Right, we'll have A to B, and then we'll have C, D. So if we're to prove this is a parallelogram, all we have to really show is the vector A to B is the same as the vector D to C. In addition, if this were to require to show it was a rhombus, we need to also show that the vector A to B length is in fact the same as the vector B to C length. So that length was the same as that length, as also showing that the above there, the A to B, is the same vector as D to C. Okay, so we've got example here. 4 points have coordinates. Show that A, B, C, D is a parallelogram for all values of K. So let's find out A to B. Vector A to B, remember from things we did last lesson, is just vector B take away vector A. And that will equal, so vector K take 2. And the next one will be B take A, so it'll be K plus 1 take away -1, which ends up as K plus 2. Vector D to C will be C take D, C take D, so that thing, take away D, so we end up with 2K take a K, which is a K. We've got -3 take 1, so that becomes add 1, so that's -2. And then when we do C take D on here, we've got 2K plus 2, just take away K, so that ends up with K plus 2. Oh look, they are the same. Therefore, as AB equals DC, it's a parallelogram. Part B of this question says, find the value of K for which it's a rhombus. So if you remember what we said about rhombus, to prove it's a rhombus, we need to show that the length of A to B is the same as the length of, say, B to C. So let me do your rhombus there. A, B, yeah, C, D. Did we do C, D that way around? Doesn't really matter. It helps, doesn't it? So we're trying to show that length is the same as that length, and then it's a rhombus. We've got to also show that they were parallel, but we've done that in the previous bit. So A to B, we've worked that one out, haven't we? A to B, got that somewhere. We did it a second ago. K take 2, K plus 2. So the length of A to B, bit of Pythagoras, Probably a messy devil. Equals something. I'm going to leave it there for a minute. B to C. I'm going to have to work this one out. So that's C take B. That take that. So that ends up as C take B gives us, yeah, K take 3. And C take B ends up as K plus 1. So the mod of B to C, or the length of it, is in fact that. So if rhombus mod of AB will equal mod of BC. So let's just pretend they are and check it works. So we're saying the root of that equals the root of that. So basically, could square both sides. And we're left with, still not very nice, but we're left with K take 2 all squared plus K plus 2 all squared equals K take 3 all squared plus K plus 1 all squared. Multiply all that out. Not very nice, is it? K squared take 4K plus 2 plus K squared plus 4K plus 4. And that last one should have been a 4 as well. So that's equals K squared minus 6K plus 9 plus K squared plus 2K plus 1. So those, that, thank goodness something cancels, not a lot, but that cancels with that. What are we left with now? So we've got 2K squared plus 4 on this side, I think. Oh, yeah, so it's 8, right? 2K squared plus 8. And on this side, we've got 2K squared minus 4K plus 10. Well, take that off both sides, gone. Take the 8 over there and the 4 over there. So we've got 4K equals 18. So K will equal 18 over 4, which is, oh, I made a mistake there. It's not 18, is it? The 8 goes over there and that's a 2. But we notice that. So that will mean that K equals a half. Super. So we found the value of K for which made that a rhombus. Next question. Find the points. The 3 points have coordinates A, B, C. Show that A, B, C lie on a straight line. So we're trying to show that A, B, C lie on a straight line. So let's find out, what is the vector A to B? Well, the vector A to B is B take A, isn't it? Which gives me 9 and a 3. And the vector B to C is C take B. If I work that one out, I'm going to get 6 and a 2. So we can see those two are actually multiples of each other. So these are multiples. Oh, goodness me, spell that wrong. Multiples of each other, and therefore they're parallel. And as they share a common point, which is B, as they share the, I don't think I need that bit. I don't want to put that there. As they share the point B, they must be on a straight line together. Quite true. Just that's a bit longer than that one, although it doesn't look like it in my picture. And if they all lie on a straight line like these, we say that these points are, you might not have seen this word before, but it's called collinear. I think I've spelt it right. Yeah. Well, part B, there's part B. Part B, find the ratio of AB to BC. That's talking about the lengths, really. So A to B, the length of A to B, I've done with a bit of mods around there, don't I? A to B, well, Pythagoras, 9 squared plus 3 squared. What does that give us? 90, I think. Root 90. And if we do the mod of B to C, B to C up there as well is 6 squared plus 2 squared, which gives us 40, root 40. So we'll find the ratio of those to each other. So root 90 to root 40. Square both sides, 90 to 40. Take the naught off, 9 to 4. Cancel that down and you should get 3 to 2. End. Okay. Example 3. The vertices of a triangle ABC, let's draw that. Have position vectors A, B, C. M and N are the midpoints of A to B and A to C. So M and N. And when it says these have position vectors, it means like coming from the origin. So you've got some origin somewhere, put it all there, saying that that vector there is a vector A, if you were just wondering what that means. Those are the position vectors. Might rub that off or it might get confusing. We're talking about position vector. Right. So A. Express the position vectors of Mn in terms of A to B to C. All right. Well, M equals a half of, so if you put your origin on here, as you can see it, would be that plus that, wouldn't it? So that's the vector A, and that from A to B is B take A, but it's half of it, isn't it? So if you go along that and up that, then you end up with half a B and half an A. So it's half of A plus B. And the vector N, in a very similar way, would be a half of A plus C. Okay, part B. Prove MN is parallel to BC. So this time, if I rub off those, oh dear, rubbed off far too much. we're trying to show here that MN is parallel to BC. Right, okay. So MN would be N take M, which if you use this, M take N, N take M, so they've got rid of the A's, haven't we? And we've got left with a half of basically C take B. And we know that BC would be C take B. So we can see from that, I think we can make it that they are parallel. That's just 2 times as big as that one. So, oh gosh, they are multiples of each other, hence parallel. Full stop. Right, I think that's enough from me. Here's a whiteboard question, so have a go on your whiteboard or on the table or on the wall at home, as long as your parents know about it. Try that question. Please pause. It says find the position vector of the point D such that ABCD is a parallelogram. Remember, to show it's a parallelogram, all we have to show is that AB is equal to CD, the directions. And then M is a point on the diagonal A to C. Find the position vector of M. Show that M is also the midpoint of BD. So please pause the video, have a go, and shortly the answers will come. So maybe unpause now. We're ready. Try to show AB is equal to DC. You find D that way. Hopefully you got D. Part B. That's the position vector of M. And part C. There we have it. Right, hope you manage those. That's enough from me, really. It says this exercise 15D, even numbers, I think will pop up in a minute. I don't expect you to do them all. You may have run out of time by now, and there may be some on the homework. I hope there are, but sometimes there aren't, because I don't control the homework sometimes. Well, most of the time, somebody else does. But everybody's got the same work. Sometimes they don't always test what we're doing in the lesson on the homework. So if you'd like to have a go at 1 or 2 of those, please do so. It's advisable. And then pause this, have a go at maybe 2 that look funny to you or good to you, and then the answers will pop up shortly. These are from the textbook, by the way, so if you want to look in the textbook for these questions, you can do. You've probably got an online textbook, or maybe not got it quite yet. Not sure. But that's what these are. So have a go, maybe at 2 of those, please. Pause the video if you've just got time, and answers will come up when you unpause. So beep, probably unpause. Here are answers. Right, then that's enough from me. We've been long enough today, haven't we? Hope you've learnt something. It wasn't all revision from your GCSE. And I shall see you back in class, hopefully all class together for some geometry. Bye bye. Oh, before I go, Vector Song. I'll put this on as an extra. You can listen to it if you want. Sung by a very famous person. You'll meet her in lessons. It's me. And You might enjoy it. Try the video coming up. It might make you smile. Anyway, see you for now.